Hello everyone, welcome to Pepcoding. In this video, we will look at the question count the triplets. Okay, so let's take this problem statement. Let's see. Here it is saying that we have given an array of distinct integers. So this is my array of distinct integers. The task is to count all the triplets such that the sum of two elements equals the third element. Now what does this mean? I need to find all the triplet values, or I need to find the count of all the triplets, which when added up, or when the first two numbers are added up, gives me the third number, which means something like 2 and 5 when added up gives me 7, right? So 2 plus 5 when added up gives me 7. So this is a valid triplet, right? This is a valid triplet. Another triplet would be uh, 2 plus 3 gives me 5, right? So this is also a valid triplet. Now 4 plus 1, right, when added up gives me 5. This is also a valid triplet. So I need to find the count of all the triplets. Now what is going to be the brute force approach for this question? What I can do is I can fix a value here, right? And I'll check for this value, and for this value I'll check the rest of the array or the rest of the vector, right? I can do that. So for 3 I'll check 2, 5, 4, 1, which when added up gives me 7, right? Then for 2, then I'll start with 2 again. Then for 2 I'll check the rest of this array, right? For 5 I'll check the rest of this array. Now that is not a very optimized approach, right? It is very brute force. So what I can do is what we can do is we can try to optimize it in some way. So the first thing we are going to do is we are going to sort this array. Okay, so let's sort this. We will get 1, 2, 3, 4, 5 and 7. Okay, we get this. Now we are going to fix our number. So we are going to take an I pointer and it is going to be fixed at the end, right? Now we will take two pointers, low and high, and we will try to find the pairs which will add up to this target. So again, we will take a pointer I, which is going to start from the end of the array or the end of the vector, and we will take two pointers, low and high, and we will try to find the sum of the two numbers, which when added up gives me that target. So let's see. Here I have my low and high as 1 and 5. So 1 plus 5 is equals to 6, and this is less than 7, right? This is less than my I value. Now this is less than my target. So I need to increase my 6 to get to 7, right? I need to increase something. So I need to increase my sum to get to 7. So if I want to increase this value, right? If I want to increase my sum, what will I do? I will increase my low, right? Because I can't increase high. If I increase high, it is going to go out of bound, right? 1 plus any number besides this array, 1 plus any number beside this array is going to give me a greater value than 7, right? So I'm going to increase my low, right? Now I will check if low plus high is equals to 7, right? Low plus high is equals to 7. 2 plus 5 is equals to 7. So I found a valid pair. So let's make a count. Let's make a count here, which is at 0. And when I find a pair of which when added up gives me that target, so I will increase my count. Okay. So low plus high gives me 7. So I'll increase my count. Now there isn't going to be any value which when added up with 2 gives me 7, because it is saying that it has distinct integers, right? So I'll increase my low and I'll decrease my high, because there isn't going to be any pair besides 2 and 5 which will give me 7, right? There isn't going to be another pair with 5 which will give me 7. So I'll increase my low and I'll decrease my high. Now 3 plus 4 gives me 7. I've also found another pair. Now this is going to be 2. Okay. Now low is going to go here. High is going to be here. Now they have intersected, which means that I've found all the possible combinations for 7, right? I found all the two pairs or all the pairs which when added up gives me 7. So I found all the triplets for 7, right? So I'll decrease my I here. And since I'm decreasing my I, my low is going to be go here, my high is going to go here. Now, for my I is at 5, right? I will check for the numbers here. Now, why am I checking for all the numbers before this array only, before this element only, before my target? Why am I checking for all the pairs before this target only? Right? Why did I sort this array, and why am I checking for the elements before this array only, before this element only? Because the only the only pairs which when added up gives me that target are going to lie in this array only. And why is that? Because there isn't going to be any number before this which when added up with 7, or which when added up with another number on the right hand side which will give me my 5, right? I won't have any other number like that besides negative numbers. So for this question, my whole concept is that I will find all the arrays or all the numbers uh, before this element only, right? I will find all the numbers which when added up gives me that target before this element only, because this is sorted, right? So all the smaller values than 5 are on the left hand side, and only the two smaller values which will add up to 5 are going to be on the left hand side of 5 only. So I am starting my low and high from the left hand side of 5 only. Okay, so this is my approach. Now I will check 1 and 4 gives me 5, so I'll increase my count again. I'll increase low, I'll decrease my high. Okay, 2 and 5 gives me 5, 2 and 3 gives me 5, so I'll increase my count again. Low is at here, high is at here, right? Which means they've intersected. So I is going to be here. Okay, low goes back to 0, high goes back to I minus 1. It checks again. 1 plus 3 gives me 4. It's a valid pair. So I get a triplet, right? Low is going to increase, high is going to decrease. They both intersect, which means I've found all the values for I. I is going to go here. Low will be here. High is going to be here. Right? 1 plus 2 gives me 3. Valid pair. My count is 6. Right? Low goes here. High goes here. Now, I won't decrease my I any further, right? Because there isn't going to be any value which is lower than I, right? There isn't going to be any value which is lower than I equals to 2. Because I need to find all the pairs, right? I need to find all the pairs which will add up to that target. And since we have an array of distinct integers, I won't find any pairs before 1 or before 2, right? So when my I is at 2, this is going to be my last iteration, and I will, as soon as it goes here, I will terminate it. Okay, so I hope you understand this approach. It is very simple. Let's just code this. So the first thing we are doing is we will sort this vector, right? Sort arr.begin, arr.end. Now I sorted this vector. I need to find a count, right? So I'll take a count. Now for loop, while I is less, will start from array.size -1, right? It is starting from the end, and this will go till 2 and I minus minus. Okay. After this for loop, I will return my count, right? Because this for loop is to check my count value. So after this for loop, I will return my count. Now in this for loop, I will calculate my low, which is at 0, and a high, which is at I minus 1. Okay. Low is at 0, high is at I minus 1. Now we will run a while loop while low is less than high, right? And also let's make a sum, which is array of low plus array of high, right? So if my sum is less than ARR of I, if it is less than my target, or let's say if my sum is equals to my target, right? If my sum is equals to my target, I need to increase my count, and I need to increase my low, and I need to decrease my high. Okay. Else if if my sum is less than array of I, if my sum is less than my target, I need to increase my target. So I'll increase my low. Else, it only means in this else condition that my sum is greater. So I need to decrease my high. Okay. So this is a very simple code. Let's run this. It is giving me the right answer. Let's submit this code. It is also passing all the test cases. So I hope you understand this question. If you don't, I would suggest you watching the part which you don't understand. Don't forget to like, share and subscribe. Thank you for watching.